Next is a formal charge. The formal charge, in case of polyatomic ions, we consider that the charge, whatever the charge, polyatomic ions means ions which is carrying a charge. So we consider that whatever the charge is present in a polyatomic ion is present on whole molecule, means there is no individual charge on the atoms. However, we can calculate the charge present on each atom in a molecule, and that charge is called as a formal charge. So what is formal charge? I can say simply that the formal charge is nothing but the charge on formal charge is nothing but the charge on an atom when it is by considering that the electrons are equally shared between both the atoms which are forming a bond, regardless or irrespective of their electronegativity. Means during the formation of a bond or during the formation of a molecule, every atom uses how many electrons. On the basis of that, we determine the charge on an atom. So here the formal charge, let I'm writing it as a Fc, is nothing but it is a difference of the charge or the electrons in a valence shell of an isolated atom minus the electron in a electron present in valence shell of an atom in a Lewis structure. So this with the help of this difference, we determine the formal charge. So it is nothing but the electron present in a valence shell of an isolated atom. Electron in an isolated atom means it is the number of electron present in a valence shell when the atom was not forming a bond. When it was isolated means simply alone. Minus the electron present in a valence shell. We all know that when the bonding takes place, during the bonding that sharing takes place, due to that sharing and all, the number of electron in the outermost shell changes. So minus the electron present in a valence shell of an atom in a Lewis structure. If the formal charge, the answer may be positive or it may be negative. If the electron in a isolated atom is more compared to the Lewis structure, then it is going to be a formal charge will be positive. And if this is more and in the actual electrons are less, then the formal charge is negative. Now, so here I can say the electron in a valence shell of an isolated atom. In a valence shell, the electron is present, that I am representing it by the capital letter V, minus the electron present in a valence shell. Now in case of valence shell, the electrons in a Lewis structure. In a Lewis structure, the electron present in a outermost shell of an atom is either in the form of lone pair or it is in the form of bond pair. We saw the certain examples in which we saw that there are the atoms which are having a lone pair electron, like chlorine when form a single bond, then it was having a 3 pair of electrons. So those 3 pair is called as a lone pair, and bond pair, that is electron which is utilized in the bond formation, that is a shared. Now in a bond pair also, if there is a bond pair electron, that is a bond pair means at least there will be, if one pair, if there is a single bond, that means there will be 2 electron, but out of that 2 electron, only 1 electron will be of that particular atom and that second electron will be of some other atom. That means if the bond pair is having a 2 electrons, and out of 2 electron only one electron is of a particular atom whose formal charge is to be calculated, and the other electron is of other bonded atom. So here I can say the formal charge, if you want to calculate, then it is the number of electron present in a valence shell minus the lone pair is totally considered as that lone pair is whatever the pair of electron is, that it is totally considered. So minus lone pair electron, that is L, minus bond pair. Out of bond pair, as I said, if there is a 2 electron, then only 1 electron is from that particular atom, the second electron is from some other atom. For example, suppose if it is A and B, I am writing. This structure is something like this, A and B, and this is B, and there is electron is shared. So if I want to know that how many electron is the structure, actually how many electrons are present, or actually how many electron A atom is having in this molecule. So I will say that these 6 electron which is present here in A part, it's a totally electron from the A, And out of these two electrons, only one electron is from the A. That means out of these two electrons, there is 2 by 2. Only one electron is from A and the other electron is of B. So here the electron present in a valence shell means we are talking about this full electron, that is called as a lone pair electron, and half of the bond pair electron. So half of bond pair electron. So this is the formula which we use for calculating formal charge. V minus L minus half of B. Valence electron in an isolated atom when it was not forming a bond, minus the number of lone pair electron in a lone pair. You did not have to write you had to write the number of electron, total number of electron. And here the half B, that is a half of bond pair electron. Okay, now let us calculate the formal charge for certain molecule. The first one I am considering ozone molecule, that is O3. The Lewis structure for the ozone molecule is O. In this case, this oxygen is forming a 2 bond. This bond, both the bonds are purely covalent. So oxygen form, if the oxygen is having total configuration 2,6. So if the oxygen is forming two bonds, means out of 6 electron, 2 electron is utilized in this, and then remaining 4 electrons. Similarly for this oxygen also, if it is forming 2 bond here, then 4 electrons will be left. And then here the oxygen, this bond is a coordinate covalent bond in case of ozone. Coordinate covalent bond means both the electron for the bond formation is given by the single oxygen. And it is given by the single central oxygen, that is this oxygen. So this oxygen will have all 6 electrons. So here this oxygen is using no electron for the bond formation. Now, here I am numbering all the oxygen just to differentiate number 1, number 2 and number 3. Let us calculate formal charge. So formal charge on first oxygen. I am writing the formal charge for the first oxygen. It is equal to oxygen, total number of electron in oxygen in a valence shell, that is when it is non-bonded. So total electron is 6. Minus lone pair electron. How many lone pair electron? Then I can say it is having 2 lone pair, that is total electron is 4. Minus half of bond pair. Bond pair, how many bond it has formed? 2, 2, 4. 2 bond means total electron is 4. So half of each bond contain 2 electrons. So half of 4. So it is equal to 6 minus 4 minus 2, that is 0. So the formal charge on this oxygen is 0. Similarly, if I want to write the formal charge on this second oxygen. Second oxygen. Total electron is again being oxygen 6 in the valence shell when it was non-bonded. Minus how many lone pair electron? Then there is only one lone pair, that is, and that too one lone pair, that means 2 electron. Minus how many bond it is forming? 1, 2, 3. 3 bond means 6 electrons. So half of 6. So it is equal to 6 minus 2, 4. 4 minus half of 6 is 3. That is plus 1. So this second oxygen is having plus 1 charge. Formal charge on this, plus 1. That means it is having 1 electron less in a structure. It is having a 1 electron less compared to the total electron present in a valence shell in an isolated form. Then formal charge on third one. Third oxygen, total valence shell electron is 6. Total lone pair electron is 6 and bond pair half of this, half of 2. That is, it is forming only single bond, so half of 2. So it is 6 minus 6, 0 minus half of 2 is minus half. That means this third oxygen is having minus 1 charge. This is plus 1 and this is minus 1 charge. And overall charge is going to be neutral because plus 1 and minus 1 is 0. So overall ozone is a neutral. But out of these 3 oxygen, I can say one oxygen is having no charge and this is having central oxygen is having plus 1 charge and this oxygen is having minus 1 charge. Then second example. COCl2. Now out of COCl2, the one is going to be a central atom, carbon and oxygen. There are the 2 atoms which can be a central, but the central atom is generally that atom which is having less electronegativity. So from carbon and oxygen, the carbon is going to be a central atom. So here in this, the Lewis structure of COCl2 is C, Cl and Cl. Each chlorine have a 7 electron in the outermost orbit, and if this chlorine is forming a single bond, means 6 electrons are left. Same thing here, I can say 6 electrons are left. Oxygen is forming double bond, that is 4 electron is left. All bonds are purely covalent. The carbon having a 4 electron in the outermost orbit, and here the carbon is forming 4 bond, that is all 4 electrons are utilized. Now, I just wanted to know that formal charge on each atom. So, right, I'm just writing this chlorine as a 1 and this chlorine is 2 and this is carbon and oxygen. So, formal charge on first chlorine. Chlorine configuration is 2,5, 2,7, 2,8,7, atomic number is 17. That is how many electron in the outermost shell? 7. Minus, how many lone pair electron it is having? 6. Minus, how many bond pair? There is only, it is forming single bond. Single bond means half of each bond contain 2 electrons. So, it is equal to 0. Formal charge in second chlorine. This is chlorine 1 and chlorine 2. This is also chlorine 2. Okay. For the second chlorine, same thing, same bonding it appears. So, formal charge is going to be same, 0. That is total electron, total valence electron 7, 6 is lone pair and only single bond. So, again the same. Carbon, formal charge for carbon. It is equal to, on carbon I can say there is a total electron carbon, atomic number is 6, so configuration is 2,4. So, outermost shall have 4 electron when it is an isolated form. So, 4 valence electron minus, no lone pair electron, but 4 bonds are formed. 4 bonds, no lone pair electron. 4 bonds means half of 4 to the 8 electron. Half of 8, that is 4. 4 minus 4 is 0. So, no charge on the carbon. Then I wanted the formal charge on oxygen. Oxygen, total electron in case of oxygen, outermost shell is 6 minus 4 lone pair and it is forming 2 bonds. So, minus half of each bond contain 2 electrons. So, 4. So, it is going to be 2, 0. So, here I can say all atoms are carrying 0 charge. It means the number of electron present in a valence shell and the number of electron assigned to particular atom in a Lewis structure is same. Then third one, carbonate ion, that is CO3 2 minus. Now CO3 2 minus, the structure of carbonate ion is C double bond O, O and this O, and this full charge present on this is 2 minus. This oxygen is forming double bond. Here this oxygen is having 6 electrons and this oxygen is also having 6 electrons. This is the structure of Lewis structure of carbonate ion. So let's see now what will be the charges, formal charges on this. At least from the formal charge I will come to know that which atom is having this, carrying this charge. So formal charge on double bond oxygen. I'm just writing double bonded oxygen, that is this oxygen. 6 valence electron minus 4 lone pair forming 2 bonds. So minus half of 4 to 2 bonds means 4 electron. So it is 0. There is a no charge on this. This oxygen number 1 and number 2, formal charge on first oxygen. It is equal to, total electron is again here also 2, 2, 2. That is, sorry, in case of oxygen total outermost shell electron is 6. How many lone pair electrons? 6. 6. How many? This oxygen is forming a single bond. So minus half of 2. So it is going to be minus 1. So this oxygen is carrying minus 1 charge. Similarly for the second oxygen, bonding appears same, the electron appears same. So I think charge is also going to be same only. So it is 6 minus 6 lone pair electron minus 1 single bond half of 2. That is minus 1 charge again. Then formal charge on carbon. It is equal to the formal charge on a carbon I can write. For carbon total electron the outermost shell is 4. Here the carbon is forming 4 bond, no lone pair electron. So half of 4 bond, that is 8. So ultimately it is going to be 0. So I can say that out of 4 atoms, these 2 oxygen is having a minus 1 formal charge. So I can say this total 2 minus charge is because of these 2 oxygen. And these 2 carbon and oxygen have no formal charge. So formal charge is just tells us that difference between the number of electron present in a valence shell and the number of electron assigned to an atom in a molecules in a Lewis structure. The difference If there is a more electrons are assigned in a Lewis structure, then the formal charge is negative, and if the less electrons are assigned in a Lewis structure, then formal charge is positive. So this is the way how we calculate the formal charges. In a exams or in an entrance exam, they ask the questions on formal charge also.